Hello, I am Kaeini. We are starting a new series of lessons. Due to the lockdown, we cannot continue the previous style. Then I'm doing this kind of lessons from home using PowerPoint. Now, first lesson is about the sequence and series. So let's see what we have. Course outlines is first lesson is about arithmetic progression. Second lesson will be about geometric progression, and the third lesson will be binomial expansion. Okay, these three lessons we are going to cover under sequences, which is mainly used in all the pre-university courses, same as Igcse and O-level and any other course like that. So let us start the course, arithmetic progression. Let's see what is arithmetic progression. Now, arithmetic progression, we denoted by AP, a sequence which the difference of any two consecutive terms is constant is called an arithmetic progression or arithmetic sequence. So let us see what I mean by this. Now, so if the first term is denoted by A and the second term and the common difference is denoted by D, then the sequence can be represented by A, for the first one is A, the second one is D unit more than A, will be A plus D, the third one will be A plus 2D, and A plus 3D, and goes on like that. Therefore, each consecutive term differ by a D, common difference. Therefore, now the difference between any two consecutive terms is D. Now, let us give some examples and see what is that. Now, consider following sequences. Determine which ones are arithmetic progressions. Now, here you have got 2, then you are adding 3, you are getting 5, then adding 3, you are going to get 8, then adding 3, you are going to get 11. Therefore, the first term is 2, and the common difference is 3, so it is an arithmetic progression. Now, here it is 2, then when adding 2, you are getting 4, adding 2, you are getting 6, adding 2, you are getting 8. Therefore, this is, again, an arithmetic progression, and the first term is 2, and the common difference is 2 also. Now, here, you are having 1, adding 3, you are getting 4, adding 3, you are going to get 7, not 6. Therefore, this is not an arithmetic progression. So this is not an arithmetic progression. Now, look at this sequence. Here is 15. To get 12, you have to add minus 3 or subtract 3. Therefore, you are subtracting 3. Again, here to this 12 to 9, you are subtracting 3. 9 to 6 also, you are subtracting 3. That means the first term of this sequence is 15, and the common difference is negative 3. Therefore, this one is also an arithmetic progression. Now, let us see. What is the general term or nth term of an arithmetic sequence? General term or nth term of an arithmetic sequence. Now, we know that the first term is denoted by A, then second term will be A plus D, third term will be A plus 2D, and the fourth term will be A plus 3D. Since the first term doesn't have D, second term has got only 1D, third term got 2D, and then fourth term 3D. Therefore, UN will be A, same as all of them, plus N minus 1D. That means this number here, whatever you are having here should be 1 unit lesser than this number. Okay, so this is the n term of an arithmetic progression. Now, one example. In an arithmetic progression, AP, the first term is 5, and the common difference is 3. Then write the first 3 terms of the sequence, okay? You can do that. then write the 10th term of the sequence. Okay, let's see what we can do. Now, you want to write the first three terms of the sequence. The first one is 5. Then to get the second one, you have to add 3. Therefore, first one is 5. To get the second one, you are adding 3. To get the third one, you have to add 2, 3. Therefore, this is 2 times 3 is 6, plus 5 is 11. Actually, you can say that you are adding 3 to this. 8 plus 3 is 11. Okay, now how to find the 10th term? 10th term, using this formula, you want U10. U10 will be A. A is 5. And then N minus 1. N minus 1 is 10 minus 1, which is 9 actually. 9 times D. D is 3. Therefore, just calculate this. You are going to get 32. Therefore, the 10th term of this sequence is 32. Now, let's see what is the next page. Now, this is worked out examples. Let's see what is the first example. In an AP, the 5th term of the sequence is 10, and the 8th term is 4. Therefore, we know 2 expressions till now. Let's see what he wants. Find the first 3 terms of the sequence, okay? Then, now let us see. When it says U5, that means A plus 4D. I told you this, if this is the 4th term, we are going to get only 4Ds. It says it is equal to 10, therefore it's equal to 10. Now, U8 will be equal to A plus 7D, which is equal to 4. Now, you can see that you have got actually 2 equations with 2 unknowns, A and D. Now, so now there are 2 equations with 2 unknowns. Then we are solving them. This is easy. If you subtract these 2, this minus this, what you are going to get? This A cancels this minus this, you are getting negative 3D, and this minus this, you are going to get 6. Then divide by negative 2, D will be, divide by negative 3, D will be negative 2. D is negative 2. Substitute in any equation, I'm going to substitute here, then I'm going to get minus 8, goes that side will be 18. Therefore, 4 times minus 2, minus 8 goes that side, plus 10 will be 18. Therefore, A is 18. Now I know the first term is 18, and I know the common difference is negative 2. Therefore, that means each time I have to subtract 2 or add negative 2. Therefore, first term is 18. Second term will be 18 minus 2, which is 16. Third term will be 16 minus 2, which is 14. Therefore, these are 3 terms of this sequence. Now, let's go for the next question. Another example. In an AP, the first term is 1236, and the common difference is negative 5. Okay. Now, how many terms of the sequence are more than 0? Therefore, we want to know how many terms of the sequence are more than 0. Okay, this is one question. Let's see, is there any other question? Yeah, which term of the sequence is equal to 261? Okay, let's see. Now, here we have the first term, we have the common difference. In both cases, we need to calculate the term, the number of the term. Therefore, n is unknown in both cases. Now, in the first case, we want to know when un or nth term is more than 0. How many of them are more than 0? Therefore, we are putting un is equal to the first term, which is 1236 plus n minus 1d. This should be more than 0. So we want to know how many n's are there. So you can expand this. You are going to get this. Then these 2 can be added. You are going to get this. And I have taken this 5 and that side. Now I will divide both sides by 5. So n should be less than 248. Therefore, 248 point something, because the n should be an integer. Therefore, 248 are positive. 249 will be the first negative term. Therefore, 248 terms of the sequence are more than 0. Now, to do this, Now this time un has been given to us. So we know the value of un, we are going to find exactly same equation, then we are going to find the value of n. You see here only I'm putting 261 and writing the same equation, a plus n minus 1b. Now you can do it this different way. You can expand it or whatever you want. This is a simple linear equation. You can solve it. Then what I have done, I brought this side. If I wrote it like this, then I subtract this, I got this. Then I divided by -5 both sides. Therefore, I got n minus 1 is equal to 195. Therefore, n will be 196. Anyhow, you can solve this linear equation. You can expand this, whatever you like, you can do. And your answer should be 169. Oh, sorry, 196. Okay, this is, let's go for, okay, sum of the terms of an arithmetic progression. Therefore, now we want to find sum of the terms. Now, for this, look at this sequence. The first sum, find the sum of the first 10 terms of an arithmetic progression, where the first term is 5 and the common term is 3. Therefore, first is 5, therefore this is 5, so the next will be 8, and continue like that. You are going to get till 32. Okay, now look at this. If you add this 5 and 32, you are going to get 37. You know that this number is 3 units more than this, and this number is 3 units less than this. Therefore, if you add these two also, you are going to get 37. You can see that. Therefore, the second one and the last, what one, that 29. If you are adding these two also, you are going to get 37. If you are adding these two also, you are going to get 37. Therefore, actually, sum of these, all of them are 37. You see, this plus this also is 37. Therefore, the sum of all this number is 5 times 37. So, therefore, the answer is very simple. You don't need to add all of them. Therefore, we can say the number of the terms divided by 2 times the first one plus the last one. Therefore, you are getting the formula actually here, 185. Therefore, the formula we have understood, always the first term and the last term, the sum is same as the second term and the last but one, and goes on like that. So the answer of Sn, sum of the n term, will be n over 2 u1 plus un, the first term plus last term. But we know that we have a notation for this, which is a, and here we have a plus n minus 1d. Therefore, a here with the a here will be 2a times n minus 1d. Therefore, this is actually n over 2, first term plus last term. Okay, therefore, this is the formula which we are using for sum of the n terms of an arithmetic progression. Okay, see one of examples. Okay, find the sum of the 15 terms of sequence where the first term is 5, 8, and the common difference is 3. Therefore, this is very simple because it's just straightforward. We can do it. Therefore, we know that Sn is equal to, is the formula, n over 2, 2a plus n minus 1d. Now, n has been given to us is 15. Therefore, just substitute 15 here. A has been given to us is 8. Therefore, 2 times 8. N is 15. Therefore, 15 minus 1 times d is the common difference 3. Therefore, just substitute all the values. We are going to get 15 over 2, 2 times 8 plus 15 minus 1 times 3. Let's calculate this. We are going to get 435. Therefore, the sum of the 15 terms of this sequence is 435. Now, let's go for another example. Now, in this example, in an arithmetic progression, the sum of the first n terms of the sequence can be obtained from Sn equal to 3n squared plus 5n. Therefore, this is our Sn. Now, we want to find the sum of the first 10 terms. Then we want to find the sum of the 11 terms till 20th term inclusive. That means 11 till 20, both of them also include. Okay, then find the first term, okay, and then find the common difference. Okay, Now the first question, part 1, is very straightforward because it says 10. Therefore, this sum of the n term. Therefore, put n equal to 10. Therefore, all the values n should be 10. Therefore, we are just substituting 10 in the formula, as 10 will be 3 times 10 squared plus 5 times 10 is 350. Now, this formula always gives the sum from 1 to the number which has been given. Now we want from the 11th till 20th. Since we want from 11th to 20th, if I substitute 20 in this formula, I'm going to get from 1 to 20. From 1 to 10, I know is this much. Therefore, if I subtract this, if I subtract S20 from S10, I'm going to get from 11 till 20th. Therefore, S20 is sum from the first term till 20th. And S10 is from the first term till S10 is from the first term till the 10th term. If you subtract, you're getting from the 11th term till 20th. Therefore, this. Now you substitute only 20 inside this. Substitute 20 with 20 squared plus 5 times 20 minus. Substitute 10 we have already done is 350. Calculate this value, you are going to get 950. Okay, we have done this also. Now, the third one is very simple actually, because he says find the first term. What is the meaning of this? This means if you are putting any number n here, from the first term to that term, the sum of them is being given. This formula gives that sum to us. Therefore, if I put 10 from first term till 10th term, will be 350. Now, if I put 1, this is the only first term. Therefore, S1 is equal to A. Therefore, just put 1 here. Therefore, S1 is equal to A. A will be equal to 8. So we got the value of 8. Now, if I put S2, will be first term plus second term. First term is A. Second term is A plus D. Therefore, S2 is 2A plus D. This is A plus A plus D. Therefore, this is the sum of the first and second term. But we know that S2 is equal to substitute 2 here. We are going to get 12 plus 10 is 22. Therefore, 2A plus D is 22. Therefore, we got 2A plus 2 is equal to 22. But we know that A is equal to 8. Therefore, this will be 16 plus D is equal to 22. Therefore, D should be equal to 6. Therefore, we got the value of D also. Therefore, we find the common difference of this sequence. Okay. Now, look at this example. This was an example from the past year papers. Just look at this. Over a 21-day period, an athlete prepares for a marathon by increasing the distance she runs each day by 1.2 kilometers. On the first day, she runs 13 kilometers. Therefore, she runs 13 kilometers first day, and each day she is adding 1.2 kilometers. And she does that for 21 days. Therefore, you know this is an arithmetic progression. The first term is this, the common difference is this, and the total number of the days is 21. Now, she is asking to find the distance she runs on the last day of the 21-day period. Okay. Now, here, find the total distance she runs in 21-day period. Okay, this is the total distance. Now, let us go for the first one. First one means, okay, they want the term 21. Therefore, U21 is unknown. You know, UN formula is this. Therefore, U21 will be A is 13. Therefore, N is 21 minus 1 times 1.2. Just calculate this. You are going to get 37. Therefore, at the last day of her practice, she is going to run 37 kilometers. Okay. And now, let's see what is the second part. Second part, they are asking total distance she runs. The total distance is Sn. So Sn, we know that is n over 2, 2a plus n minus 1d. N is 21. We are substitute 21. 2 times a is 13. And 2 minus 1, 21 minus 1 times 1.2, which is common difference. So just put in the calculator, we are going to get 525 kilometers. The total distance she runs over this 21 day is 525 kilometers. Okay. Now, let's see. An arithmetic progression has the first term negative 12, and the common difference is 6. The sum of the first n term exceeds 300. Calculate the least possible value of n. Therefore, we want to know that if we keep on adding these numbers, when it goes over 3000. Therefore, the sum of them, we want to see this sum. Therefore, you have to use Sn formula. Therefore, Sn formula is this. N is unknown. We want to see how many terms. N is unknown. Therefore, A is minus 12 and D is 6. So this should be more than 3000. Therefore, you just substitute. Therefore, this is the equation you are having. This should be more than 3000. Now, it's a matter of simplification and solving a quadratic inequality. Okay, now just multiply this inside and then expand this first, and then first simplify inside the bracket and then expand this. You are going to get something like this. Take this 3000 also this side and simplify this. You are going to get something like this. You can divide everything by 3. You are going to get this. Therefore, this is your equation. Now, solve this equation. You are going to get 2 answers, one negative, one positive. Surely negative is not accepted. N should be more than, you're getting N more than 34.22. Therefore, N is 35. The first number more than this is 35. Therefore, the first number which is sum exceed 3000 is 35. That means if you are adding 34, the sum will be less than 3000. But if you are adding 35, the sum will be more than 3000. Okay. Another question we are having here, it says that A, B, and C are 3 consecutive terms of an arithmetic sequence. Show that A plus C is equal to 2B. It's very simple to do this. Only thing you should know that the fact that B minus A is D, the common difference. Okay, then C minus B also is the same. Therefore, this is actually, you can say, in general, any term minus previous term should be D. In general, it's like that. Therefore, since they are consecutive terms, therefore, if the common difference is D, then we can say that B minus A is D, and also C minus B also is D. C minus B also is D. Therefore, these two are equal. Therefore, these two should be equal. Therefore, B minus A is equal to C minus B. Then just bring this to side, bring this side. Then you can see that A plus C is equal to 2B. Okay. This is the first lesson summary. What we have learned in this lesson was this. Okay. You should be able to recognize the arithmetic sequence. Therefore, if you are getting a sequence, you should know that this is arithmetic or it is not arithmetic sequence. By checking that, the common difference is constant between all the terms. The second thing you should be able to find n term of the sequence. You should know un is equal to a plus n minus 1d. Now, another thing which we have learned here, the sum of the first n term of the sequence. So this is Sn equal to this. Other thing, other than these 3 things, all other things are actually algebraic expression, and you should be able to manipulate algebra. That means same as solving inequalities, solving quadratic equation, and also simplifying expressions. Thank you for watching. I hope this was helpful. Now we'll continue the second lesson later. Thank you.
Audio Jungle.